Welcome to qnawire.
In this problem, we're looking at an argon-ion laser, and it has a cylinder-shaped beam whose average power is 0.750 watts. And we want to know, in a 2.5 meter length of this beam, how much energy is there contained in that volume of beam. So first thing we want to look at is that the total energy in that section of beam is going to be equal to its energy density, that's U, multiplied by the volume. So energy density within a given volume to get the total energy. Well, for a cylinder, volume of a cylinder is going to be area of the circular shape multiplied by the length, in this case, that 2.5 meter length. And so we have a total energy, I'm going to call that ET, is equal to U times the area times the length. Now, we don't know what the area is, and we necessarily won't need to, but we do know L, so let's see if we can figure out what U is. We have a relationship between intensity and the energy density. That's just intensity is equal to C times U. So if I rearrange that to solve for U, I get U equals S over C. Let's try plugging that into our equation for total energy now. ET equals SAL over C. And now we have the intensity in there in place of the energy density. It's a little bit closer to what we want because we can then use this other equation relating the power to the intensity. As power is just intensity times area. And so we can see that intensity times area, well, that's in here already, SA. So we can just substitute P in for that. So this is now PL over C. And so that's the total energy right here. We can go ahead and just plug in our numbers. Write it over here. Total energy is equal to 0.750 watts times the length, 2.5 meters, divided by C, which we're using 2.9979 times 10 to the 8 meters per second. Plug all that into your calculator, and you're going to get something like 6.25 times 10 to the minus 9 joules. And that's the total energy, that length of the beam.